So
So would I write it all out as one thing, like one negative, like 1 minus 2x2
yes,
negative, and then everything else? I wouldn't like, okay, so I
well,
wouldn't like solve them and then
no.
turn each one and then, okay.
One small
So it's
thing
not
though,
one
sorry.
whole, oh, sorry, go on.
One small thing is that you put the second one in parentheses because you're subtracting everything. So it has to go in parentheses like this. But you're not solving them individually. You're putting them together and then distributing the negative to both.
And you put a 1 right there to do and then you would just flip the signs for distributing
Exactly,
for if
exactly.
it's just a negative.
Yes, 1 minus 2x squared minus 4x squared plus 3. And then you've got to combine like terms.
Then that would be the -4 and 2 with the exponents. And we wouldn't combine those. Would we combine those exponents?
No, you would
No?
keep
All right.
keep it
the same.
as, yeah, it's like eggs and bacon. Keep it, still eggs, still bacon if you like eggs and bacon separately.
And
Right.
then the 1 minus 3 would be,
It's
how is that?
positive.
Or it's positive, but that's a negative. So it's 1 minus +3 or no? Oh, that's a -2. Never mind. I was looking at it. So it would just be 4.
Yes, yes.
Okay.
Okay. Now, similarly, I can, and I'll bring these down. You can just go the other direction and do it in reverse here. So let me have you try that one here. Actually, I don't like where that, there we go. So I could ask you to do g of x minus f of x. Okay, so why don't you try this one and see what you come up with.
So I would do that same one.
It's switching order though. So like the previous one
Oh,
was f minus g, and now you're going in the opposite direction. So you got to put the g first. Make sure you can see it, g first, and then subtract the other one in parentheses. And it's a sign. It's really a sign error. You got to make sure your signs are all right.
4x squared -3. And then in parentheses, it would be the 1 -2x squared.
That's right.
And then I would put a negative sign there, right? Or no? Because it's subtracting.
You want to change the signs of everything inside parentheses.
Okay, so then it would be a -1 +2
That's right.
x squared.
Yes, you got it.
And then you would just combine the same ones, but it would be different because the signs are different. Like it would be
That's
positive.
Yeah, I mean, it ends up being exactly opposite of what we had before, but that's just
Yeah.
because of the way this problem worked out.
Yeah, the same numbers back and forth.
So give me your final answer whenever you've got it.
It would be 6x squared and then -4.
Yes. Yes, good. Do you want another adding and subtracting, or do you want us to move to multiply?
Do a multiply.
Okay, so I'm going to do the same thing here. I'm going to give you some functions here. So h of x is going to equal 2x, and g of x is going to equal 3x minus 1. And we're going to take h of x and multiply it by g of x. Okay, so here's how that looks. You write the function 2x instead of h of x. And then the 3x minus 1, it's really in parentheses. They just wouldn't write it in parentheses. And now it looks like something you've already done. You have to distribute that 2x to both terms inside parentheses. Do you know what I mean by that, or is that unclear?
Would it be that same thing where we do 2x times 3x? And
Yes.
then, so for the rule of the exponents with that, would that make it a squared because there's one of each?
Yes. Yes.
Okay. And then 2x times -1 would be -2x.
Yes. Okay, so I'm gonna,
And then that's final because there's nothing we can combine.
yes, so let me make another function here. Let's say f of x is 3 minus 4x. So I'd like you to do h of x times f of x.
What did you? I can't see. Oh, there I go. I can move it. All right. So 2x times, and then that second one would be written in parentheses 3
Yes.
-4x. So 2x times 3 be 6x, and that's positive, right? Because it's a positive.
Mhm.
6x, and then -4 times 2x. That would be -8x squared.
For
Or no?
for the second one, yes, it'd be 6x minus 8x squared. Yes.
Okay.
Any questions on that?
Mm-mm.
Okay, so let me just give you a couple new functions here. So let's say f of x equals x minus 5, g of x equals 2x plus 1. Now when we multiply f of x times g of x, you're going to use FOIL. So we covered this last time, but we can certainly review it. FOIL means to multiply the first times the first, the x times the 2x. The O stands for the outside ones, x times the 1. The I is the inside ones, minus 5 times 2x. And then 5 times 1 is the L there. Do you remember us doing that? Do you want me to go through it, or do you want to try this one on your own?
I'll try this one on because I think I remember the first, inner, outer, last, and
Yes.
then the way we were doing it before, we were like writing FOIL and then like lining it up and then basically like writing it out.
Yes. But you really
Okay.
want, you just want to write the answer
Yeah.
out, without all those other things.
And we multiply those, like multiply so it would be 1x times 2x,
Yes.
the
Yes,
first
exactly.
one.
Yep.
So it would start with 2x
2x squared.
or
Because
oh,
you
because there's 2. Okay.
yes.
2x squared, and then outer is 1x. So it's 2x, or no, time 1x, just 1x by itself,
Yes. Plus 1x. Good.
plus 1x. And then inner would be -5 times 2x. So that would be -10x.
That's right.
And then the last one's -5 times 1. So it would just be -5.
Good. And then you can always, not always, but usually you can combine the outer and the inner. The O
Yeah,
and the I.
the two. Yeah, okay. So the 1x and the -10x. So then combine those, it would be it would be, what was the rule for the
So
negative numbers?
yeah, I mean, you've done them all correct. So, but since they're opposite in sign, you figure out which one is further from 0, which is the -10.
So it would be -9x.
Yes. Yes.
Okay.
Very good. -5. So let me give you one to try here on your own. Let's go 4x minus 3 times x plus 2. You want to try that one on your own, and then we can
Yeah.
probably move into dividing polynomials after this.
Okay. I'll do that last one. So 4. Two. So 4x squared plus 8 negative 3x. So all at the very end, does it end up being 4x squared plus 5x negative 6?
Yes, very good.
The 10. Oh, thank you.
Fantastic. Okay, so just a couple of questions to make sure we're on the same page for what you think we mean by dividing or division, polynomial division, because there's a lot of potential things here. So the most common case is I give you something like x cubed minus 2x squared plus 3x minus 4 divided by x minus 1. Is this what you're referring to, or are you referring to something more like x to the 5th minus 3x squared over x?
Any of those really, I hadn't even really started with the dividing yet, because there was a lot of like fraction sort of stuff involved in the beginning. So
Okay,
just
let's look at the problems on the right first, and then we'll do some other division stuff. So we'll look at some problems like this to start out. So when you're given a problem like this, it'll say something like to simplify or to reduce, and the issue here is that you have to divide both of these by the x, so you end up splitting it apart. It's x to the 5th over x minus 3x squared over x. Okay, and now there's some exponent rules. So you mentioned one of them earlier, which is if the bases are the same and you're multiplying, you add the exponent. So an example would be like x squared times x cubed is 2 plus 3 x to the 5th. But when you're dividing, you subtract the exponents, top minus bottom. So an example would be like x to the 7th over x cubed becomes x to the 7 minus 3, or x to the 4th power. Okay, so just a small, incremental step here to remember that when you're dividing, you subtract the exponents.
okay.
Okay, so on the left here, x to the 5th over x to the 1, that's 5 minus 1. Do you agree with that? Is that okay? Minus,
So the
now,
x4, x
Yep.
to the 4th eventually.
Yep. And then on the right here, the number is not affected, but it's x to the 2 minus 1 power.
So it would just be 3x.
Yes. All right. So, not such a big deal here. Let's look at another problem here. Let's go 9x to the 8th minus 3x to the 6th over 3x to the 4th. Okay. So the key here is to again to recognize that you have to divide like both of these. It's not a choice. You have to do both. So it's 9x to the 8th over 3x to the 4th minus 3x to the 6th over 3x to the 4th, like that. So in this example, the you do have to divide the numbers, 9 divided by 3, and then you have to use the exponent rule. So this is 3 x to the 8 minus 4 power.
So it would be 3x to the 4th.
Good. And then on the right, bless you, I don't know if you're sneezing there. On the right here, they divide out, so that's minus 1 x to the 6 minus 4 power minus 1x squared. And these are not like terms, so you can't combine them.
Okay, so that's the final answer then.
Yeah, that's it. So let me give you one to try here. Let's go 8 x to the 6th minus 4x cubed over 2x squared. So go ahead and work that out and see what you come up with.
Okay. Yeah. Would it be 4x squared minus 2x or negative 2x?
Yes. Very good. Very good. Okay. So there's not really much more to say about that. So let me jump to another type of problem, which is kind of related. So let's just say I wrote something like this: x minus 1 in parentheses.
Wait, I have
X
a
minus.
question about
Sorry.
the.
Okay.
Sorry, I just thought of these are like ones that like go into each other evenly. Will there ever be one where like there's a remainder? Is there anything? What happens with that?
Well, that's what we're building up to, and
Oh, okay.
I
So
was
that's
trying
the
to do
longer
it.
kind.
Yeah, and I
Okay.
was trying to do it incrementally, so you
Okay.
didn't, we didn't just like forget this could be a problem on the test, and then you should be able to get this right. Like let's not skip over the easy stuff that the low hanging fruit, if you will, on there. So what I was trying to show you here is, let's just say you had something like this where it was x plus 2 on the bottom. So you have x minus 1 up top, x plus 2 up top, and an x plus 2 on the bottom. Do you agree that these cancel?
I guess so.
Okay, so maybe we need a little more. So let me give you another example here. Let's say it's 4x to the 5th, y to the 4th over y to the 4th.
So would those cancel then too?
They do
Anything like
cancel.
anything if it's above, and
Yes.
would that work if it would it ever be like cross?
So you can kind of think of these as just columns, but they're all in the same place. Like if I give you, let me give you a different example here, where I put something like 8a squared b to the 5th over b to the 5th times 4. There's no equal sign, so you can basically rearrange. You can put the b to the 5th here so that they
So I
do
could still
cancel.
cancel them out.
Yes,
If so, basically, if the same thing shows up in on the top and the bottom, I can cancel it.
exactly,
Okay.
exactly. Okay, and so those cancel. 8 divided by 4 is 2. The answer is 2a squared or something like this.
Okay.
So it extends though, and that what I was trying to get to is it extends to a problem like this, where it's x squared minus 5x minus 6 over x minus 6. Okay, so this is kind of a basic or level 1 polynomial division problem, but you really need to factor the numerator, and I don't know if we've talked about that yet.
Mm.
I don't know if I don't think we
That's kind
have.
of where it started in the book, and that's why I wasn't able to get this far.
Okay, so let me
Just confused me.
choose one easier than this to factor. So let's because you're really good at foiling. You're really good at foiling. So you would foil this and you would find that this is x squared plus 3x plus 2. And the question is, how do you go backwards? Backwards is factoring. Okay, and that's what I guess we should talk about now, is how to go backwards. Is that okay?
Yeah.
All right, because it's somewhat related.
Because this
So
is what I wanted to brush up on fractions for specifically is factoring.
okay, so the factoring here, the type of factoring, there's a number of different types of factoring. We're just going to work on this type right here. You're trying to find two numbers that multiply to 2 but add up to 3. So what I always recommend is coming off to the side here and writing the factors. So the factors of 2 are 1 and 2. Do those add up to 3?
Mm-hmm.
So you write x plus 1, x plus 2. Now keep in mind that we already knew the answer, so this is kind of trivial because we already knew what the answer is going to be. But in the next problem we won't know what the answer is. Okay, so let's look at another one here. Let's say it's x squared plus 5x plus 6. Okay, and it would say something like factor.
So would I have to find two numbers that both go into 6 and add up to 5?
Multiply to 6 but add to 5.
Oh,
And
okay.
and if you can build a comprehensive list
So it would be 3 and 2, and
to,
then
and so you write x plus 2, x plus 3.
okay. And is it always, what if there's more than two numbers? How do I know which one to
There,
start?
there will
Always
only
the end?
there will only be two numbers that work.
Oh, there will only ever be two
Yes,
numbers?
but the challenge is finding them. I don't know if you like those types of puzzles or games where that's the challenge is like getting the thing that works.
Yeah, I've got to figure out which ones I would need to factor in each
Yes.
problem.
So here's a problem for you to look at or try. That's not too difficult. Two numbers that multiply to 12 but add to positive 7.
4 and 3?
So your answer will be written this way: x plus 3, x plus 4. The order doesn't matter. Like if you wanted to say x plus 4, x plus 3, that would be fine. So the only way these get more difficult is two things. The first is I make the number bigger on the end. Okay, let me show you that here. So I make this number larger on the right hand side. Two numbers that multiply to 44 but add to 15.
Mm. So it would be written as x plus 11, x plus 4, or the other way
Yes,
around.
exactly. Yeah, or the order doesn't matter. The second thing I can do to make this more difficult is to use a number besides, or use a letter besides x, but that doesn't change what you're doing. It's just a distraction. It's still two numbers that multiply to 18, add up to 9. So could you try this one for me, please?
And I'm going to try to do the tree thing for the 18. So how do you do the little tree right there?
So
Would I do like,
I start with 1 times 18, and then I just go to the next number, 2, and they get a multiply to 18. So 2 times what gets you to 18?
a 9? And then
9. Then I try
8,
3.
or yeah, 3.
Okay. And then you could try 4. 4 does not work. You could try 5. 5 does not work. And 6 you already have. That's how you know to stop, because you've already wrapped around.
Okay, and then it is, yeah, because it's 6 and 3 for the 9.
So what do you write in parentheses?
X plus 3 and then x plus 6, or the other way around, either
So
way.
it's got to be C.
Does it
And that,
matter? Oh, no, sorry, C, yeah. But just whatever.
now they
What if there's,
sorry, go ahead.
is there's only ever going to be one variable, huh? And then I just put
Yes.
whatever variable it is.
Well,
Okay.
for now, there's only going to be one variable.
Oh,
But I don't think they would have like the answers with X instead of C. But if you were in an online homework, you might, you'd get a they would say this is the X would be wrong because they want C. So you might feel like, hey, I've got it. Like that's really easy. And then I throw a problem like this at you and you realize like, oh, there's actually more to this. So the first type of factoring I showed you is what I call the plus plus. The answers are both positive. This one's different. Two numbers that multiply to 27 but add up to -12. So if you start writing the factors here, these both add up to positive numbers. So is there another way to get there? Yes, there is. You have to make them both negative.
Okay, so it would be the 9 and 3, but negative, -9, -3.
X minus 3, X minus 9. Yeah. All right. And again, this is where it gets a little more challenging because you have to recognize that, yeah, it's 27 positive, but you can get there by making them both positive or both negative, and you have to be able to, choose the right one. So I think you understand this. Let me give you one here to try that's not, not too crazy with numbers, magnitude of numbers. Try this one on your own. See what you come up with.
So it's x2 or two numbers that add up to
Multiply to 16.
16, but add up to -10.
Yes.
And 16. Oops. So this one would be x minus 2 and then x minus 8.
Good. So the challenge is in the identification. It's recognizing like which type is this, because once you know which type it is, you know how to do it. And I'm giving you all problems of the same type. I'll give you one more here to look at before we move on to the next one. Do you have a question for me? Is this still making sense?
Yeah, I'm just counting.
Okay.
The calculator. I think it's would be a negative or a -8.
Yes. Good. Really good. Okay. So, you might think on a, now I've got it. and then I show you yet another type, and there's only really 3 types, maybe 4, but this one's the hardest. This one's the most confusing, I suppose, but I think you're going to understand it because you've done really well in the examples we've done thus far. Okay, so new problem here. X squared minus 6x minus 16. Okay, x squared minus 6x minus 16. Okay, so two numbers that multiply to minus 16 but add up to -6.
Mm.
So now it's 1 and -16 that multiply to -16. But then you also have to consider the other possibility, -1 and +16. 2 and -8. Again, these are what multiply to -16, -2 and 8. And then 4 and -4 are your last ones.
Mm.
Is that clear how we came up with this list?
I think so.
So basically it's one positive and one negative, but you have to switch them also because one of these will add up to -6. Can you tell me which one that is?
It's the 2 and the -8.
Yeah, so this becomes x minus 2, I'm sorry, x plus 2, x minus 8. And the order does, like, the signs matter. Like, it has to be plus 2, it has to be minus 8.
Okay.
All right, so let's have you try one here. This one's easier than the one we just did, so maybe this will go well. Um,
It would be x plus 1, x minus 5.
yeah, really good. Okay, so let's just increase the difficulty a little bit. These are the most difficult, so we're gonna just do a bunch of these. You clearly have done factoring because you're not at all phased by this, at least as far as I can tell. So give this one a try.
And it's what would add up to +2.
Yes, multiplies to -15 and adds to a +2.
And then basically everything that adds up to 15, I would do like 3 and 5. I would do like -3 and 5 and -5 and 3.
Exactly. Yep.
Okay. So would it be x minus 3, x plus 5?
Yes. Really good. Really good. Do you want to try one more, or do you feel like you've got this?
I'll try one last one.
Okay.
S- So it would be b minus 5 and then b plus 10.
Yeah, really good.
Okay.
Really good.
And just sometimes with the bigger numbers, it takes me a bit because I'm not that fast with the multiplication trees. Takes
Yeah.
me a bit to find all the factors of it, and I have to go and divide it by every number. Calculator.
You're doing really well. And I mean, I think just, if you want like my opinion of the past, weeks, you've gotten faster. Just doing it, I'm sure helps. So, so here's a problem. This is why we're learning what we just learned. You might get something like this and it would just say to simplify. Okay. And simplify, well, you can't just like divide. Okay. The reason you can't divide is because there's really parentheses here. So you first need to factor. You need to be able to factor the top. Then you need to be able to factor the bottom. And then you hope that things cancel.
So
Okay. So
you would find out what multiplies to 12 adds to 8, and
yes,
then vice
exactly.
versa for the bottom, and then you would rewrite it
Yep.
with
Uh,
those answers,
yes. So let
and
me
then see
help
if
here
it cancels.
for the, yeah, let me help for the first ones. The first one is x plus 6, x plus 2 for the top. And then on the bottom, it's x plus 6, x minus 3. Okay. Now the question is,
Okay, and then we could cancel out those x and 6s, and
that's right.
then could we cancel out those other two x's, or would, because those are all together, those don't cancel?
They cannot cancel. They're in
Okay.
parentheses. It's better to treat them like they're in parentheses. And yeah, it's like what you just asked is a question a lot of math students ask, and it's no, you cannot cancel this.
I'm just making sure there's not another step I'm missing.
Yeah, no, but here is one for you to try. Let me snip this in. It's got the factoring we've been talking about. So give that one a try and see what you come up with.
Let's see. 2. So when I'm factoring the 18, I should make everything negative because one is a negative and one's a positive. It's when, or is that when I write one of each?
So in the case of the 18, because you're trying to get a negative 11x,
Do I write everything as negative?
yeah, that's right. That's
Okay.
right. That's right.
-1, -18. So as basically kind of as a little rule, if they're both negatives, I should do the both vice versa. And then if it's a positive and then adding up to a negative, all negatives.
Yeah, I can summarize that here. There's 4 cases, but I can summarize them shortly. But yeah, yes,
Okay.
there is a pattern, which I think is what you're asking for.
So the top would be x minus 2 X minus 9.
Good, good. Now here's a hint. One of these will be in the bottom one or both. So that could help you to figure this one out.
Like the same thing for canceling.
Yeah, you're either going to see an X minus 2 down here or an X minus 9 because there's going to be a cancellation. So that's a hint. That's like, hey, nudge, nudge, wink, wink. This is going to work out, nicely.
Okay, so for the -8, I would do like the negative positive thing.
That's right.
Okay, so 1 and 8, 1 and 8, 2 negative. So the bottom would be X -2, X +4.
That's right.
And then you just cancel out that first one, and then the answer would be that second one.
Yes. Good. Really good. So you were asking about the factoring cases. So let's say it's an x squared plus bx plus c. I call this the plus plus case because your answers are x plus something, x plus something. It also happens to be a plus and a plus.
Okay.
The next ones we did tonight were x squared minus bx plus c. This is the minus plus case, and it becomes x minus x minus. And then there's actually two other cases here. It was x squared minus bx minus c, x squared minus bx, I'm sorry, plus bx minus c, and these both become x minus a number, x plus a number. So in terms of the signs, it's a minus minus or a plus minus that leads you to this.
Okay.
So it's a lot to remember. Just be careful. I mean, I don't want you to get overwhelmed, but because you did all of these correctly. Sorry, go ahead.
Oh, I was saying that makes sense because it's kind of shown up as a pattern with all those problems that it
Yes.
ends up like that.
Yeah. So in terms of factoring, we can actually do a bit more on factoring if you wanted. There's 5 types of factors that you need to do. The first is GCF, which we have not done. Difference of
The
squares, greatest common
I know the
factor.
greatest yeah.
Perfect square trinomials, which are kind of like what we did tonight. The type we did tonight are called A equals 1. And then 5 is A not equal to 1, or these are called grouping problems. So we did those. We could work through some of these other ones in a future lesson if you would like.
Yeah, because the only factoring I know of is like the least common denominator, greatest common factor stuff, which I guess greatest common factor is the only one of those that's actually factoring.
Yes.
Okay,
Yes.
Is the difference of squares more geometry thing?
No, it's factoring. It's just that's the name they give it in books. I don't know. They're not really square, but that's what they call it. So,
Oh, okay.
I don't
Because
know.
I haven't gotten past this, and I know there's geometry past this. So wasn't sure when it starts to come in or like what. How
You could transition to it at any time. I mean, it's gonna be things like line segments and areas and volumes and perimeters and stuff. But
I figured I'd do that last because it's going through like the algebra stuff. Because after this, I think it's like equations or whatever, where you would like figure out like what is x, that sort of thing.
yes,
Yeah. So that's after that. I'll have the geometry be last because I feel like pivoting into that from algebra will maybe give me a better understanding.